So section 7.2 is properties of parallelograms. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So again, if we look at this right here, we see that we have an arrow here and here. So those are the same, and 2 arrows here and 2 arrows here. So they're telling us that those are parallel. So what we can say then, ladies and gentlemen, is that line segment QR is parallel to line segment PS. And we can say that line segment QP is parallel to line segment RS. Okay, and again, remember you could go in the other direction. So knowing that, we have some more theorems here that we can talk about. So the first one is parallelogram opposite sides theorem. So if a quadrilateral is a parallelogram, then its opposite sides are congruent. So again, if you kind of look here, those are the same tick marks, and those are the same tick marks. So what that is telling us then is that we can say that PQ is congruent. So since we're talking congruent, remember it has to be a line segment to SR, and we can say that line segment QR is congruent to line segment PS. Okay. And another one, parallelogram opposite angles theorem. So if a quadrilateral is a parallelogram, then its opposite angles are congruent. Same thing here. This one has one arc and that one has one arc. And this one here has 2 arcs and 2 arcs. So on this here, we can say that angle P is congruent to angle R, and angle Q is congruent to angle S. All right, so we're going to use those here for this first example. So find the values of X and Y. So since we know that the sides are, so again, it's showing us it's a parallelogram. So we know that this side here and that side there are equal. So we can say, oops, sorry about that. And let me find it again here. There it is. Sorry about that. I just added a couple minutes on the thing, didn't I? So let's see here. I just said that those sides were equal, so we can say that 3y minus 1 is equal to 20. So we can say that 3y is equal to 21. And if we divide by 3, we can say that y is equal to 7. And the angles, opposite angles, are congruent. So we can say, if they're congruent, remember, that means they are equal in measure. So we can say that 2x is equal to 54, or that x is equal to 27. Okay, now the next one, again, this one should make sense, the parallelogram consecutive angles theorem. So if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So we've kind of talked about that one before. So we can say that if I look at this one here, right, we know by a parallelogram, and we know that those are consecutive interior angles, right? So we talked about that in chapter 3, I think. If lines were parallel, then their co-interior angles are supplementary. So same kind of thing here. So it's just telling us that x degrees plus y degrees is equal to 180. And they're kind of saying, doesn't matter which way you go, because these ones here would also be supplementary. Well, they're both x and y too. So if you went all the way around, you would see that they would still be all supplementary. I really got to figure out how to quit doing that. All right, so example 2. In parallelogram Pqrs, so they're saying we have a parallelogram here. And they're calling it Pqrs. They're saying that the measure of angle P is 4 times the measure of angle Q. So find the measure of angle P. Well, if it's 4 times the measure of angle Q, let's call Q something. How about X? So if Q is equal to X, then P would equal to 4X. Again, it's a parallelogram, so we know that those are supplementary. So we can say that X plus 4X is equal to 180. Or simplifying, 5X is equal to 180. Divided by 5, we'll get that X is equal to 36. Again, be careful here, ladies and gentlemen. Again, read the directions carefully. I gave some extra credit on your test, your last test, where some of you gave me the measure of the external angle and I didn't ask for that. So I still gave it to you. I give you half credit at least. So we'll read the directions carefully because not everybody's going to be as nice as I am. All right. So it asks us to find the measure of angle P. That is what we need. So we know that the measure of angle P is equal to 4 times X. So we will have 4 times 36. And if we plug that into our calculator, we would see we would get 144 degrees. All right. And I think this is our last theorem for today. I mean, I have a couple problems for it, but this is the last theorem. So, parallel diagonals theorem. If a quadrilateral is a parallelogram, then its diagonals bisect each other. So if its diagonals bisect each other, kind of look what is happening here. We can say that QM is equal to MS, and we can say that PM is equal to RM. So let's write down what I just said. QM, line segment, is congruent to line segment SM, and PM is congruent to RM, and those are line segments. Okay, so let's look at the two. We're going to use parallelograms in the coordinate plane. So first one says, example 4, find the coordinates of the intersection of the diagonals of parallelogram ABCD with vertices at 1, 0, B is at 6, 0, C is at 5, 3, and D is at 0 and 3. So let's go ahead and do that. Let's keep it at blue. I'll use my diagonals as red. So we said A is 1, 0, B is at 6, 0, 1, 2, 3. And this is A. We said that C is at 5 and 3. So 1, 2, 3, 4, 5, up 1, 2, 3. And D is at 0 and 3. So what did I do wrong here? Oh, B is at 6 and 0. My bad. It's a good thing I can see my mistake because I knew it just wasn't looking like a parallelogram. So B is at 6 and 0, so I'm going in the X direction, my bad. So 1, 2, 3, 4, 5, 6. And I won't edit that. I want you to know that I do make mistakes too. So there's A is at 1 and 0. B is at 6 and 0. C is at 5 and 3. And then we know that D is at 0, 3. There we go. Again, the x direction, the y direction. Now, that looks better. All right. So now we just talked about how the diagonals bisect each other. So I'm just going to go ahead and draw them. And remember, sometimes it doesn't look perfect here. But we know that our midpoint, because they bisect, we know that that point right there is the point of intersection. Let's just call it M. So we plotted the points, connect the points, and draw the diagonals, which is what we just did. Step 2 says by the parallel diagonal theorem, the diagonals bisect each other. So since they bisect each other, you know that the coordinates of the intersection is the midpoint of the diagonals. Now, sometimes you won't have to do that. You'll just have to state what the values are. But on this one here, for this example, you're going to find one of the midpoints. And that's all we need because we know that they bisect each other. So find one of the midpoints. And let's see. I said I'm going to find the midpoint. Remember, I just called it M of AC. And if we recall, the midpoint is the x coordinates. So 1 plus 5 divided by 2. And it's the y coordinates. So it's going to be 0 plus 3 divided by 2. And if we work that out, 1 plus 5 is 6. 6 divided by 2 is 3. And 0 plus 3 is 3. And again, we're going to have to find out which way the Big Ideas platform likes. I keep telling you to just leave it as a fraction. I'm sure if you put it as 1.5, they'd probably be okay with it right there too. So let's go ahead and see. Does it look like we were pretty good there? So is our x direction 3? So there's 1, 2, 3. And then it's 3 halves is about 1.5. So there's 1. There's 1.5. Yeah, it's pretty close. It's right, spot on, people. We did good. All right, and then our last one here. Again, I'm not sure whoever did the homework, I'm not sure if they gave you one like this, but I thought it was a good problem. So, and you never know. You might have to do it sometime. So 3 vertices of parallelogram DEFG are D is at -1 and 4, E is at 2 and 3, and F is at 4 and -2. Find the coordinates of G. So step 1, graph vertices D, E, and F and connect the points. So let's go ahead and do that. And let me go ahead and switch back to blue here. And let's make sure I do it right this time. So D is at -1 and 4. There's D at -1 and 4. And let's see, E is at 2 and 3. So over 2, up 3. So there is E. And then it said F is at 4 and -2. So and what did they just tell us to do? They told us to connect the dots there. So if we connect the dots, here's what we have so far. Okay. So we did exactly what they asked. And then, so on step 2, they want us to find the slope of DE. So if we find the slope of DE, that's this one here, right? They want us to find that slope. So remember, slope is y2 minus y1 over x2 minus x1, which is 4 minus 3, and again, negative 1 minus 2. And if I do that, I'll get 1 over negative 3. And remember, that negative can go where you need it to be. It could go on the top. It could be on the bottom. So that's why a lot of times I'll just put it right out front, because then you can choose which one it'll help you out with. So now remember, since DEFG is a parallelogram, opposite sides must be parallel. So what we're going to do is we're going to start at point F. All right. And when we start at point F, we're going to go according to what our slope says. So our slope for F and G should be the same as our slope for D and E. So that means that we're going to go 3 units left. From point F. So remember, when we go 3 units left, 1, 2, 3, that tells us we are going, well, let me keep it in red for you. That tells us we're going negative. So there's my negative sign right there. And then we're going to go up 1. Right? So if I go up 1, that's where our point G should be. All right? So we're going to plot point G. All right, so let me go ahead and I'll just go ahead and cover that red one there. We're going to call it G. And it looks like our G point is at what? 1 and negative 1. And then we are going to finish our parallelogram. All right. So what did we just do? We just showed that this line here by the slope is parallel to this line here. So now to prove that it is a parallelogram, all right, we have to verify that DG, that this line here is parallel to this line here. And to do that, what are we going to do? We're going to find the slopes of both of them. So the slope of DG, okay, again, I'm going to use a y2 minus y1 over x2 minus x1. So I'll have 4 minus a negative 1 over negative 1 minus 1, which will give us 5 over negative 2. So let's put it out front again. It's negative 5 halves. The slope of EF, again, I'm going to just, again, it doesn't matter which one you choose as x1, y1, x2, y2, all right? But just remember, just stay the same. So I'm going to have 3 minus a negative 2 over 2 minus 4, which is also 5 over negative 2, which again, I can bring it out. And I'm always saying just bring it out, because what if the negative was on top? It would still be negative 5 halves for both of them, ladies and gentlemen. So we know that is okay. And so we are good. And so we can say coordinates of G are 1 and negative 1, which is what they wanted.